Yeah, okay. Um, I decided to talk about a couple of fractions in 3D trigonometry and further mathematics of Edexcel syllabus, right? So I have discussed so many fractions. So this is an assignment given for students last week. So I decided to discuss this one. Uh, the diagram shows the cylinder, right? So then AB and B points are on the circumference of the circle. C is the center of the circle. ABC is a triangle. Now we can see that ABC must be a line along the vertical plane exactly because when we connect these two center points of this top and bottom surfaces, well, those are circles, it becomes a vertical line. Exactly, it is vertical with the horizontal surface with the circular surface, right? So then uh, this should lie, this triangle should lie along that vertical plane, right? So this is the vertical axis. Um, right now, it is the diameter. Okay, okay, right. So we have to compute theta. So what do we do in order to compute theta? Yeah, what we can do? We can apply sine rule, apply sine rules on ABC triangle, right? Okay, now 7.8 centimeters over sine 32 degrees, right, equals 12.4 centimeters over sine theta, right? Now you can see sine theta equals 12 point, sorry, 12.4 centimeters. Centimeters will be cancelled off. 7.8 times sine 32 degrees. Then what I want to do is we can get sine inverse of both sides, right? 12.4 over 7.8 sine 32 degrees, right? Okay, now so this is the answer for the first question, right? So we will compute it, right? So you can use a calculator. Just compute the sine inverse 12.4 over. Make sure whether your calculator is set into these angles are set into degrees or not. Otherwise, you have to convert that into degrees. It's better to check whether it's working fine or not in advance, right? By checking with sine 30 degrees or something else, what you know exactly sine 90 degrees equals just 1 or sine 30 degrees equals 1/2. You can make sure whether it's working fine or not with your calculator, right? So I get only two significant figures, then you have to pay attention on the third decimal. 57.4 degrees, right? 57 point theta equals theta equals 57 point 57.4 degrees, right? In degrees. right? Okay, now even you could compute this angle because you know included angles of a triangle, which is 180 degrees, right? Hence you could compute ACB angle as well, ACB angle as well, right? Okay, somehow now you want to compute x. Actually, there are a couple of ways to compute x. What is the most easiest way? While you have found out this theta angle theta, um, what is the most easiest way to compute this x? You know, while these two are parallel, they are ordinate angles, right? So this angle equals theta, right? So you can say by paying attention on ADB triangle, you can say x over uh, AD, right? AD is nothing else, just the diameter of that circle, right? It is given by 7.8 times 2 because it's twice like the radius, right? Okay. Then x equals 80 times 80 times tan theta. Now it's time to substitute all these values, then we can simplify it with the help of calculator. This 2 times 7.8 centimeters and tan 57.40, right? Okay, degrees. Still, I have that angle on my calculator, right? Okay, even you can store that in your calculator in order to using the exact value, right? You can get a better value for little x. Actually, it doesn't matter. It's up to the significant level what you have expected, right? Uh, so I used to store uh, in my future videos. I will add scientific calculator on the other side of this computation. Then it will be easy to manage calculator for your answer. Right? So your answer is your calculator can be oriented for the answer conveniently that can be simplified, right? Okay, so I used to store that as store it as right. Okay, now 2 times 7.8 times 10, right? Because you know that the opposite side over the adjacent side equals tan theta, right? Ratio equals tan theta tan x, but in degrees, right? They have put the sign degree. Then says it's just 24.39, what, right? 24.39 centimeters, right? 24.39 centimeters, x equals, right? Okay, height of the cylinder equals this one, right? So we will go forward now. Right, okay. I'm trying to go forward now. What we need for the all the factors what we wanted to find out evaluated now at this moment. If you want to find out AB, now you have AD and DB with you, then with the help of Pythagoras theorem on this plane triangle, you can find out AB, right? Okay, so I have developed this question further. I wanted to make it a little bit complicated because you know that we are allowing of those type of questions when it's being complicated, it's being interesting as well, right? So now I wanted to include a tetrahedron inside this cylinder, and the base of the tetrahedron, base triangle will be um, quadrilateral triangle, right? So all these sides are equal with each other. Then you can imagine in your mind it is set with all the vertices of the base triangle will touch or will be overlap with, will be aligned on the circumference of the bottom surface, right? Bottom circular surface, right? Okay, now you can imagine how it will be look like. Give me a few moments. I want to store this answer. I store this answer uh, as y. Right. Okay. Now we know this angle theta and angle y as well, right? Sorry, not angle y, but the vertical height of the cylinder as well. Right. Okay. I used to clean this and go forward. Now I wanted to add this into my complex. So right. Okay. Let's add it now. It will be look like this. This is the base triangle, right? So a little bit hard to draw, interpret it over there. Anyway, I will try my best to do it, right? So right now, here, here is a tetrahedron, or we can call it as a triangular-based pyramid, right? Right. Okay. This base triangle is kind of three-lateral triangle. Now you have the idea of equilateral triangle. It's nothing else, just with equal three sides. Then all these angles are equal with each other. And while this is a plane triangle, this is each of them are 60 degrees, right? So now let me call this P, right? This is P. This one is B, I'll this K, and this is Z, right? Okay. So what about C? C is the center exactly. So let me change the color. C is the center exactly. While C is the center exactly, it will look like this, right? So actually there are a couple of ways to do this same question, answer to the same question, but I'll be going through the most convenient way because time is limited, right? So somehow if you need further methods, just please be kind enough to let me know, right? Okay, now these are radius of the base circular surface, right? It's nothing else, just CB. CB equals that's the radius, and CS and CK. all of them are equal with each other. CB equals, CL equals, and CK equals with 7.8 centimeters, right? Okay, now what do you want to do further? Actually, I have not created a question regarding this one. So what's the question I wanted to give you is I want you to find out total external surface area of this tetrahedron, right? Read carefully. Vertical axis should be created. Right, okay, it's fine. Now, you can see how there is a right triangle and it's in the vertical plane. It's in the vertical plane, right, of the sheet, right? So this is the bottom surface. In order to find out uh, this surface area, you can see terminal three triangles. Those are propagated around this vertical axis. They are symmetric. They are symmetric about around this vertical axis. So no need to find out three times. Just only the area of let me call this vertex as C prime. Just it's enough to find out the area of C prime LP. Then you can make it twice of that. Get twice of that. Then the addition between that part and the base triangle. Base triangle is something quite different because you can see its height and radius. They are quite different, right? So base triangle is a quadrilateral triangle. So that's the sole thing we know for now, right? And the axis of this tetrahedron and cylinder are overlap together, right? They are known, right? So in advance we have computed angle theta. Theta is known, right? And the height of the cylinder is known, right? Okay, I think first of all it's better to find out this side, VL, right? VL side. It means actually you have found out all these sides. VL, how do we compute BL? BL, so I'll make a construction. I'll extend this over there from the center point. I'll extend it over there, right? I'll extend it up to this one. Then you can see this is the perpendicular bisect because it is produced from the center point to the core, right? So this is the perpendicular bisect. See, let me call this E, right? Then CE is the perpendicular bisect. Now what we can do, actually KCE are collinear because of the symmetricity. You can consider KEL triangle and KEB triangle. Then you can realize that they are congruent with each other. So you can decide that KCE must be collinear, right? Exactly. Right, okay. Like this, so you must be able to realize this is 30 degrees because this is the angular bisect as well, right? This radius CB is the angular bisect as well of KBL angle, right? So likewise, we want to find out BL. How do we find out BL? There are a couple of methods to find it out. I think simply you can apply, you can apply sine rule on LCB triangle, right? You can apply sine rule on LCB triangle, right? This is the LCB triangle. Even we can follow up with, we can reach up to the solution with the help of projections, but in this case I used to apply apply sine rule on LCB triangle, right? LCB triangle. What is this LCB triangle? We don't know BL. BL is the function we have to solve for BL, right? Then what is the corresponding angle opposite with respect to the side BL? This is the angle. It's twice like this. If this is 60 degrees, this must be 120 degrees, right? Sine 120 degrees or equals with BC, right? BC is known. It's just the radius of this uh, base circle, right? BC over sine 30 degrees, right? Okay, I don't have enough space over there, so I'll use this space, right? Then make PL the subject, right? You can see BC times sine 120 degrees or sine 30 degrees. Yes, you can keep doing it with your calculator. So otherwise, what about this? This can be written as sine 180 degrees minus 60 degrees because 120 is going to be equal with this one. When we used to write it down like this, it's nothing else, it's just sine 60 degrees, right? So we know that sine 60 degrees is just the square root of 3 over 2. Then this is sine 30 degrees, it's just 1/2. Then and then we cancelled off these two may be cancelled off when we substitute it over the BC equals 7.8 centimeters, right? Then 7.8 centimeters, 7.8 times square root of 3 equals 13.509, 13.51, and we round it off, right? 13.51. BL equals 13.51, right? So not only them, not only BL, but also CK, sorry, KL and BK. All these three sides are equal with each other because it's an equilateral triangle, right? Okay. Then, okay, now we'll find out the space BL. Now we need this perpendicular height because actually in the syllabus we have not derived any equation for finding out the area of a triangle while we know all three sides. Actually there is an oriented equation. It's like this, but it is not in our syllabus, so I will not depend on that here. All these sides they are denoted with general notations, and S equals the half of the perimeter of the triangle. It's like this, right? This gives us the area exactly, but we are not allowed to use such equations here. So what we can do is you can find out KE, right? How do you find out KE? Now you could find out, yeah, there are a couple of methods to do. I just do it at once. The E equals B is the midpoint of LB exactly because CE is the perpendicular bisect for BL, right? So BE equals half of BL, 13.51 over 2, right? Centimeters. Then it is known, and we want to find out KE. Now we can write down considering KEB triangle, regarding KEB triangle, it's its right triangle. So KE is the opposite side, KE over BE equals, KE over BE equals tan tan 60 degrees, right? Tan 60 degrees. It's going to be equal to tan 60 degrees. KE, we don't know KE. KE equals then BE times tan 60 degrees, right? Okay, what about BE? 13.51 over 13.51 over 2, then times tan 60 degrees is just square root of 3, right? Tan 30 degrees, right? Okay, please just compute it a couple of times if I have made any mistake, right? 3.9 becomes 3.9. KE equals 3.9. Now the perpendicular height becomes 3.9 centimeters, right? So we know the perpendicular height and we know base as well. And we have the capability of finding out this area of this base triangle, right? So let me compute it and let me check with the help of this equation. Let me check whether it is correct or not, right? But you are not allowed to use that. But this will be interesting when you work out with practical sessions outside. When you go outside, when you're not allowed to find out when there are some obstacles, when you are not able to find out perpendicular heights and bases, especially perpendicular heights, then you can depend on this equation, right? Okay, here area of KLB triangle equals 1/2 times BL times KE. All these facts are known now. BL equals 13.51 times, then KE equals 3.9, respectively. You can just compare whether they are correct or not. Then times 13.51 over 2, right? Okay, it becomes 26.34, right? 26.34 square centimeters, approximately. Actually, this is approximated, right? Area of this triangle becomes 29.3, sorry, 26 point, right? 26 point. 26.34 square centimeters. This is the area of the base triangle approximately. Now we want to find out. Let me store that, right? Let me store that. I have stored that in my calculator, right? Okay. Now it's too easy. The last thing what we want to do is we can find out the area of this C prime LB triangle, right? So what we can do in order to finding out the area of that triangle, so now we have found out these facts, right? Okay. What we can do? Actually, base is the common side. BL is the common side for C prime LB triangle as well, right? Let me draw C prime LB triangle over here when it's unfolded. Seems like this. They are overlapped together, right? They are overlapped together. This is L and this is B and this is C prime, right? Okay, now if you could find out this perpendicular height, we got the redemption then, right? So this perpendicular height is exactly this one. let me draw it over there. It's like this. Or you can see it. It's like this. It's like this. Right, okay. There are a couple of ways to find out this C prime E, but we have to follow up the easiest method, right? Someone can consider C prime C E triangle, it's a right triangle, right? Someone can say will depend on C prime B E right triangle, C prime. Actually, we don't know what about C prime E then and C prime B as well. You know, only BE at that moment, right? So they can say C prime CP right triangle. It's a right triangle as well, which is lying along the vertical plane of this plane sheet, right? So they can do the same with the help of the suggested method, proposed method, but I think the most convenient way to find out C prime E perpendicular height for this uh, vertical triangle, sorry, this triangle, this terminal triangle is we can consider C prime E right triangle. It's a right triangle, right? You know CE is not computed directly, but you can derive CE because you know KE. KE minus KC. KC is the radius, right? Okay. Hope you can find it out. Right. Okay. Then you know C prime. It's nothing else. Just it's just little x, right? It's just the height of this cylinder, right? Height of this cylinder. It's just height of the cylinder. What about the height of the cylinder? I have stored it. I don't remember. What is it now? Right. Okay. Um, maybe I don't remember. What about the what about little x? I think should be. Okay, I'll recompute that, right? Um, so C prime E prime can be considered. Then C prime E equals C prime squared of C prime E squared equals by applying Pythagoras theorem on C prime E by applying Pythagoras theorem on C prime E right triangle, then becomes C prime E squared equals C prime squared plus CE squared. So C prime equals a little x, nothing else. It's just the perpendicular height of this cylinder, right? Uh, so let me find it out. This one over this one equals this one over this one equals 7.8 times 7.8 times 2 times and theta equals yeah okay yeah I can remember now. I have stored it as y, then 24.39, right? Square root of 24.39, square root of 24.39. Even there is a specific key program operator you are given on your scientific calculator. Now this time later, I'll show that how to do with the help of those keys within a few seconds, right? CE equals, what about C, right? This is C, right? CE equals, it's just 0.8 times it should be 3.9, right? 3.9, is it 3.9? No, there must be something issue with this one, right? BE equals half of this one, then KE over BE equals tan 60 degrees, that's all right. Then K equals B times tan 60 degrees. What's wrong with it? Yeah, we have done something mistake when we find out the L. Let's check whether the L is exactly it is 30.51 or not, right? 7.8 times sine 60 degrees times 2 equals 13.51. It's all right. Is divided by 2. Then it's 6 point. Right. Okay. This times and 60 degrees and 60 degrees. It's 11.7. Actually, when I compute this, this has not been divided by, when I use the calculator, this has not been divided by 2 exactly. That's why I got a wrong answer. K equals 11.7. According to that, the area of that will be changed, right? So this is 3.9 squared, right? Okay. Yeah, it's 3.9 squared. Right, okay, now 3.9 squared plus 24.39 squared equals square root of the answer equals 24. It's just 24.69. Yeah, it can be. But it's pretty close with the orthogonal height, the covariant height of this cylinder. Right, we can see that C prime E equals 24.70 centimeters in centimeters, right? Now we can find out the area of these terminal triangles as well, right? So hope you can finalize it. right, yourself, and please make changes on this one, right? Okay, for now I'll execute by here, right? If there is anything you have, if you have any doubt, please be kind enough to let me know. If there is any simplification issue, please just let me know, right? Okay, thank you.